Okay, 15D, properties of mean and variance. Well, as I said, those two formulas still working for continuous random variable. Like it is always true, like doesn't matter what distribution you have, okay? So also the standard deviation one still works. That is the absolute A, SD, X. Well, that was still working. So all of that is still working for continuous random variable. But today we're not going to only talk about what is the mean, what is the variance, what's the standard deviation for the new random variable. Instead, I also want to talk about what's the new distribution. Okay, what's the new distribution for the new random variable? Take, for example, I want to talk about expect value of ax plus b, right? I want to talk about expect value ax plus b. So ax plus b is my new random variable, like it's a new new thing, like new random variable. But it follows with x, like what x doing, like it times x by a and then plus the b onto that value. So basically, they are not exactly the same as your x, but it's kind of the same because they follow what x is doing. When x increase, well, it will have a particular pattern with x increase or decrease. So therefore, I make x dash like this new point. Well, originally I have random variable like random variable x, and we have density function fx. Okay, so for this random variable x, it follows density function fx, and I can find mean, expect value, so on by using fx. Now, like, well, with a given domain, let's say given domain is m to n. Well, just pretend like it's a new, with a domain m to n. Well, it can be positive infinity to negative infinity, like can be anything. Now I have a new random variable, but it's not something like really completely new. I said that's an x dash. So what x dash equals to? X dash will equals to ax plus b. Okay, a loss of x plus b with a linear transformation. Well, doesn't matter what x have, I will times that by a and then plus b. What I want to think about is what's the distribution for fx dash? Okay, what's the distribution for fx dash? I want to know the distribution. Okay, I want to know the distribution. Like this one with a particular rule, fx equals to what? I want to know, maybe I shouldn't call that f. I should call that like gx dash. I want to know the new function. Like f is original. Okay, f is with a particular rule already. But now I want to think about what's the new density function for x dash when x dash is ax plus b. Okay. Because what we can think that as transformation. Okay, we can think that as a transformation. When the new random variable equals to a loss of the old random variable plus b, can you tell me what transformation happened to this new x? Like dilation, translation, what actually happened? Well, we talk about DRT order, so what's the dilation? A, okay, dilation, we times the old one by A. So this is a dilation by a factor of A from which axis? From y-axis. Okay, and then translate B units. Well, absolute B units either to the left or to the right. Well, I don't know whether B is positive or negative. Well, it depends on what's the B. B is positive, then transfer to the right. Negative, transfer to the left. So this is what happens to the new point. Okay, new point is the old point times by A and then plus B. Dilation by A and then translate by B. Okay, so I want to sub things back, right? I want to sub things back. I have fx. What we have here is an x. Okay, this is an x, it's an old one. So I need to make x to be the subject in order to substitute back. Okay, in order to substitute back, I can say that's y equals to, the density function is y equals to the fx. The new one, this is the old one. Then the new one will be y dash equals to, the new y is, we sub what old one equals to now into the function. Okay, this is just purely from the transformation point of view. We just sub things back. How we can sub things back? The new point. Okay, I make the old point to be the subject and I sub the old one back into the function. But consider about this. What I have done, like if the new point is ax plus b. Okay, think about, I have an area. Well, let's just think about that. I have an area. If I dilate by a factor of a from the y-axis, I'm stretching it this way, right? If a is 2, if a is 2, like original area looks like this, like original curve looks like this, but with endpoint here and here. And then I stretch it, if a is 2, stretch it by 2 times, it will become like this, right? Like the area will become that, like you stretch it. And then move b units to the right. Well, right for you is this way. Okay, so b units to the right. This is the new area. Okay, I have an original area looks like this. If if a is 2, then I stretch it by 2 times. The new area become that. For a density function, what's this original area should be? 1. Okay, but if I stretch it by 2, what happened? 2, right? It becomes 2. It's not a density function anymore. Your density function needs to satisfy is 1. Okay, what else you can do can make this area back to 1? You can halve it this way, right? You have changed the x already. Now you can change y. This is 1 again, because 2 of that is a 1. So I have stretched it this way by 2. Then I need to halve it to make it back to 1, because my density function needs to satisfy 1. Whether you move to the right or move to the left doesn't change the area. So the area is only because you stretch it, let's say the length has been stretched a times. Well, if a is a half, then it's actually you doing this. Then you need to add, you need to stretch this way by 2 to make it back to 1. So therefore, you can't only change the x side. The dilation can't only happen to the x side. It also needs to happen to the y side. Therefore, you need to times a 1 over a in front of the whole function. The reason is you times by 2. Then you need to halve it again to make the area back to 1. If you have 3, then you have 3 area. Then you need to like make a third of the whole area to make it back to 1. So you stretch it means to make it large, or you make it like compressed like to a smaller area. But the area is no longer 1. I need to make it back to 1. Therefore, I have changed my x side already. My x change is already ax plus b. I can't change that part. So the only part I can change is make the height either higher or like shorter to make the area back to 1. So my whole purpose is make the whole density function back to 1. Okay, the whole density function. After I change the x, the new coordinates to the old coordinates to the new coordinates, my graph has been stretched as well. Therefore, I need to make it back into the original total area, which is 1. Okay, so this is my new density function. This is my new density function. So that's why we have x minus b over a and also have a 1 over a in front. Okay, also have a 1 over a in front. This is the logic why. Okay, it's totally because of this area. I can't just enlarge the area or make the area become half or a third. I also need to change the y side. If I change the length, I can also change the width. Okay, if I change length by 2, I can change the width by half. Then I can make it back to 1. Okay, this is the idea of how we can get the density function for the discrete random variable. Okay, this is the continuous, it's only working for the continuous random variable because only continuous got the density function and can think about the area under the curve. Okay, so let's just do one example. Let's just do one example. Okay, we have fx here. Okay, we have fx here. Fx is only works in between -1 to 1. Okay, all of these x, they are old x. Okay, they are original x. They are original x. So first of all, the first question asks expected 3x plus 1 and variance 3x plus 1. So if it's asking 3x plus 1 and variance 3x plus 1, what I can do is find expected x first. Okay, find expected x first. Expected x is integral from -1 to 1, x times fx. Okay, x times fx. And integral between the given domain. Well, if I can see this integral, that's 3x cubed over 2. So it will have x to the power 4. Well, you have a 3 over 2 is the coefficient. And you have x over 4. And you need to divide that by 4 as well. Okay, that's the antidif value from -1 to 1. And that is, if you sub 1 in, that's 3 over 2 times a quarter minus 3 over 2 still times a quarter. So the expect value is actually 0. Expect value is 0 because you sub 1 and sub -1, you have the same value. It's a quartic. So expect value is 0. I also need the variance, so I can go for expected x squared. That's -1 to 1 x squared times 3x squared over 2 x squared times fx of the x. Well, 3 over 2 is the coefficient. That's to the power 4, so to the power 5 over 5. X to the power 4 plus 1 to the power 5 and then over 5 from -1 to 1. Okay, I can see there's a lot of coefficient. Okay, this is a lot of coefficient. It's all here. So that can be a 3 over 10 outside. Okay, and just put them outside and sub 1 into x to the power 5, that's 1. Minus, you sub -1 in, that's -1. So you minus -1. That is a 2. So that's a 3 over 5. 3 over 5. So variance x equals to ex squared minus ex. Well, I'll use mu squared. And that is 3 over 5 minus 0 squared. And that is still 3 over 5. Let's double check that. -1 to 1 x squared times 3 over 2 times x squared b0 dx. That's 3 over 5, and if that is an x, I have 0. Okay, so variance is 3 over 5. Variance is 3 over 5. Okay, when variance is 3 over 5, I can think about A. A asks you about what's expected 3x plus 1. That is 3 expected x plus 1. And it's 3 times 0 plus 1, that's just 1. Variance 3x plus 1, that is 9 variance x. That is 9 times 3 over 5. 27 over 5. Okay, B is expected 1 minus x. I can say that's minus EX plus 1. Okay, minus EX plus 1. That is still 1. Well, variance minus x plus 1. That is still variance x. And it equals to 3 over 5. Negative 1 squared is still 1. So we have variance x, which is 3 over 5. Yeah, this is all revision stuff. Any problems for that? If not, let's have a look at the next question. The next question says, find the rule of the probability density function for 3x plus 1. Okay, for 3x plus 1, let's make x dash equals to 3x plus 1. Okay, you are looking for the density function for x dash. Okay, for x dash. First of all, let's look at what fx is. Fx is 3 over 2x squared. The new density function will be what? I will make the x to be the subject, is x dash minus 1 over 3. The new density function, okay, the dilation is 3. Okay, this has been stretched by 3 times. Then I need to make it shorter, like make it compress this way, become a third. So it will be the new density function, or I can use gx dash to represent that. Okay, I can use a gx dash to represent. It will be a third of f x dash minus 1 over 3. Okay, A is 3, so it's a third that way. And then there's a dilation 3 this way. Okay, horizontal way 3. So just sub x dash minus 1 over 3 into the function f. So what gx is? Gx is a third times, okay, fx is this. So it's 3 over 2 x dash minus 1 over 3, then squared. Okay, then squared. What I have here is this 3 and this 3 can cancel. This is a half x minus 1 over 3 squared, and that equals to 1 over 2 times 1 over 9 times x minus 1 squared. Okay, square the top, square the bottom. The bottom is a 3, so square that is a 1 on 9. So what I have is 1 on 18 times x dash minus 1 squared. Okay, this is the new density function for 3x plus 1, like for the new x dash. Okay, this is the new density function. But one more thing needs to be aware of is the domain. Okay, it's the domain. Your original x is in between negative 1 to 1. Okay, in between negative 1 to 1. So 3x will in between minus 3 to 3. Then 3x plus 1 will be in between negative 2 to 4. This is your new domain. Your x dash will be in between negative 2 to 4. The domain is not going to be exactly the same as before. Think about, you have a stretch, you have a movement. So the endpoint is no longer stay where it is before. Okay, so stretch it, then move it. So it's no longer stay as the original position. So overall, I can say this is a density function for like g x dash is a hybrid function with 18 x dash minus 1 squared when x dash is in between -2 to 4 and 0 otherwise elsewhere. Okay, so this is your new density function. What I have done, I have just subbed x minus b over a into the original function and times that by 1 over a. And times that by 1 over a. It's not going to be really big questions on this point, like it's not really has been tested before. I can't think about that from my memory, but it's just something on the book, and you think about like I think it's more about transformation point of view, not really like continuous random variable. The only thing you should think about is I still want to make the area become 1, because the area for any random variable it should be 1. So when you stretch something by n times, you need to make it shorter by n times as well to make the area still back to 1. And then you can think about the domain. The domain is just times whatever value you times and then plus the value you have. That will give you the new density function. Any questions? Okay, if you don't have any questions, the next 20 minutes, you just complete everything in this booklet. Like anything you haven't finished, you need to finish by this weekend, and also you can do the questions on the scheme of work.